Alright, so let's take a look at this question talking about momentum and calculating it. So it says the image below shows two ice hockey players moving towards each other. They collide and then move off together. So that's important. I'm going to underline that there. They move off together. And now in the diagram we can see the values. Before the collision, the mass of player A is 78 kilograms and is moving with a velocity of plus 7.5 meters per second. But player B is moving in the opposite direction. He's moving towards A. So therefore he has a velocity of minus 5.5 meters per second and his mass is 91 kilograms. Quite a bit bigger. So now it says during the collision, the total momentum of the players is conserved. What is meant by momentum is conserved here. So here we just have to think of the law of conservation of momentum. That states that the total momentum before a collision is equal to the total momentum after the collision. So that is all that we need to put here. So I'll write total momentum before collision equals total momentum after the collision. Easy mark there, hopefully. Now, immediately after the collision, the two players move together to the right. And this is calculate the velocity of the two players immediately after the collision. So to model this, I'm going to put the two players together as a block. So I'll put it as a block here on the right hand side. Just call it after. And they're moving together to the right. So we know they're moving this way. But they said they want us to calculate that velocity that I've underlined. So let's call it a velocity v meters per second. If they're moving together, A and B, put that in the box. That means that their mass can be considered as combined. So their mass there, we can have a look. That's 78 plus 91. So those two added together, that should be 169 kilograms. So that is the combined mass of both of the players moving to the right hand side. So now we can look at the total momentum before and then add it, each should be equal to the total momentum after. So let's look at that. Total momentum before. Now if we take each player individually, so let's take the player A, it should be 78 kilograms multiplied by 7.5. And then remember it's a total momentum, so we're going to add it to player B, who has a mass of 91 multiplied by that negative minus 5.5 meters per second. So plus here, brackets 91 times minus 5.5. So if you put that in your calculator, you get a momentum of 585 plus minus 500.5 for player B. So then the plus minus makes it a minus, so 585 minus 500.5, and you're left with a value of 84.5 kilogram meters per second. Remember, that is the unit for momentum, so I'm going to put that there. Okay, so now we have the momentum before. Let's write an equation for the total momentum after. So total momentum after equals, now the mass, we said it's that combined mass, so 169 kilograms for both of them, multiplied by the velocity we don't know yet, so we call it v. 169 times v is 169v. So that, remember, total momentum before should equal the total momentum after, so we can equal those last two values together. So that's 169v should be equal to 84.5. So therefore, to get v, we just divide both sides by 169, so v equals 84.5 over 169, and that gives you a value of exactly 0.5 meters per second. So we know that it's positive in value because both of the players are moving to the right, so we can just leave it at 0.5 meters per second.